Hello. In our last video we introduced the if statement, and you can see an example of an if statement right here, where an if statement has a condition that it tests. If that Boolean expression evaluates to true, then the statements, and there may be several in this part of the if, will execute, and if that Boolean expression had evaluated instead to false, then only these statements in the else part would execute. And we can see that sort of flow in this diagram here. The specific problem we were solving was complete all of these holes along the edges of this room, and we don't know yet where the holes will be, so we don't want to hardwire the robot to complete this by making this square dark, because it's possible there will actually be a wall, and it's possible there won't be a wall here, so we're going to need to check if there's a wall before we go inside of this space and fill it in with a dark square. Now, let's bring up the program we've written so far. Our program says to complete a room, complete one side 4 times. Well, that makes sense. There's 4 sides to a room. And to complete a side, we complete a wall 5 times. That turns out not to be a good plan, although it's part of a good plan, right? We do want to complete a wall 5 times. But if you look at this, well, first of all, we said at the end, the next side is supposed to be on the robot's left, which means the robot is not allowed to stop here facing up. It's got to have turned right so that this wall is now along the robot's left-hand side. So we need to turn right at the end, and I have a turn right method already defined for you in this room file. My file is called room. I'll prove that to you. Here we go. It's called room. And I'll prove that there is indeed turn right in this file. So we need to complete 5 walls and turn right. But actually it's a little trickier than that, because we also need to move, right? It's not just enough to complete the wall, we need to advance. But we don't actually advance 5 times. There are only 4 moves, 1, 2, 3, 4, when we complete 1, 2, 3, 4, 5 square wall pieces. So 5 places we need to complete, but 4 times we have to move. So we complete, then move. Complete, move, complete, move, complete, move, complete, turn. So complete, then ask the robot to move, and we'll move between each completing the wall, and after completing the last wall, if we were to move, we would crash into this wall here, so we'll turn right. Okay, that's complete the side. Now we have to actually, I like to hit compile just to feel good about this, so I'm hitting the F5 key that compiles on my computer, and it says it can't find a symbol called complete wall, and that's because I haven't written complete wall. So let's write complete wall now. Public static void complete wall. What does complete wall do? Complete wall, remember 2 slashes lets me make a comment here. Complete wall, well, beforehand, what has to be true before? Well, possible wall to robot's left. What should be true afterward? Well, afterward, if it was clear, darkened if was clear before, darkened to the left if it was clear before, and robot in original location and facing its original direction. Okay, so that's what complete wall is supposed to do. So let's begin. What's the first thing our robot has to do? Well, it should turn left. Okay, now that the robot is facing that possible wall, what does it have to do? Well, if we move and it's clear, that's great. We'll be in this open space. But if there's a wall here and we move, we will crash into the wall and the program will stop right then and there. So that's no good. We don't want to move. So that means we need to check, is there a wall there or not? And we look up how to do that, and we see, there's something called robot.front is clear, and we can use that in an if. So let's use our first if now. If, and in fact, I'm going to write out the whole outline of the if, and I recommend you do this anytime you write an if, just so that you don't forget any part of the if or any of the punctuation. Write this whole piece of code like this. If, I'm going to separate it so you can see it better. If, parentheses, braces, else, and these curly braces again. Okay, so what's my condition? Well, the condition is I want to use front is clear, which means there's no wall there. If front is clear. And I write that exactly like I write a method call. And in fact, it is a method call. We'll find out soon enough. If the front is clear, what do? Let's go back to my picture. If the front is clear, oh, that's great. I just walk in there. But I'm going to make a note. This means robot is facing a wall. This means robot facing empty square must darken it. So this is an excellent idea. When you're writing your ifs, in each part of the if, make a comment to yourself about what you know must be true if we get to that part. If the front is clear, the robot's facing an empty square and we have to darken it. And then we might do so much work in here we'll forget what's really going on when we get to the else. And in our else, we want to remember that we know at this point the robot is facing is facing a wall because the front was not clear. So let's write each of these parts. The robot is facing an empty square. What do we do when we're facing an empty square? We have to darken it. And that means we have to go into that empty cell and make it dark. What do we do when the robot is facing a wall? Well, you might say, let's do nothing. But here's the problem. At this point, the robot, let's see, the front was clear, so the robot is on the dark square, which is in the border of my room. Here, the robot is facing a wall, so the robot is in the interior of the room. Well, the problem is, the robot's in two different situations, so if I try to write code now, after my if, I won't know which of those two situations my robot is in. So, one key idea whenever I use an if is I want to make sure I leave myself in the same situation regardless of which pathway through my program I took. So, we can accomplish that by getting the robot so that it's no longer on the dark square in the border, and that it's back in the interior of the room facing a wall. And then we'll be in the same situation in both cases. So, how do we do that? Well, that means the robot's here. I guess the robot needs to back up, and luckily for us, I've already defined a backup method in this file, like we did in a previous video. So we'll say in my room file, backup. My robot will back up now, and that's good because now the robot is facing a sort of pseudo wall because we've made it dark, so it looks like we've completed the wall. And the robot's in the interior of the room. So we're in the same situation regardless, so we can continue. What else was our method supposed to do? Well, we darkened if we were supposed to, that's good, but we're supposed to leave the robot in its original location and direction, and we're in the original location because now we've either backed up to this spot or we never left it, but we're facing into the wall, and that's no good, so we need to turn right. Let's see, room file, turn right. Alright, let's give this a whirl. Compile, compilation complete, that's good. Let's try it out. Oh, it's going very fast, but doing pretty well here. Of course, I should tell you the first time I wrote this program, it did not work first try, and I spent a while debugging it, but I wanted to save you from watching me flounder like that. I'm sure you'll get to see me flounder often enough. So let's see, test complete room 1. Excellent, we've completed the room. And notice the robot is now facing in this direction because it now has the next side along its left-hand side, just like we told it to. After completing a side, it turns and so that the next side is on its left. Alright, now for the real test. Let's complete a different room, a room with a different shape. I happen to know this one won't work because this room is more complicated. So let's, I'm going to hit enter, and I should tell you, test complete room, these methods that I've been calling, they simply call, they load the room, make the robot fast, and then call the complete room method that we wrote that completes the side 4 times. So let's try that out. Let's see if I can make this pop up faster. There we go. Okay. Now here, we did well. We completed these 2, and then we crashed because this cell here has already been completed. Or is already dark, and so now we need to deal with what if it's already dark. What if it's already dark? And we could read this error message and see, oh, apparently we made something dark that was already dark, and we could go back and figure out where that happens. Let's see. It left my room program on line 58 and then went off into making dark when it was already dark. So I'll look at line 58. There's the call to make dark, and apparently we shouldn't always call make dark because it's possible it's already dark. How can we do that? How can we only make it dark if it wasn't already? We'll use an if. We'll use an if. So here's an if inside of an if, because an if is a statement, an if has statements inside it, so we can put an if statement inside of an if. So if something, and again I'm writing out the entire if. Let's see. If, now what do I want to test? What could I test for here? Robot on dark. I want to know if the square is already dark so that I don't darken it. So if robot.onDark, I fill in the condition. If the robot is on dark, what do I do? Well, nothing. I don't have to do anything. It's already dark. But otherwise, I want to make it dark. So we'll fill that in here. If it's on dark, do nothing. Otherwise, we can go ahead and make it dark. Either way, I now know the robot's on a dark square by the time I leave that if. So let's compile that. F5, compile, it's happy, and we'll test completing room 2. There he goes, and it looks like we've probably done it. Let's see it finish. Yay! In the next video, we'll see some ways of simplifying these ifs that I've been writing and learn a little bit more about ifs. I'll see you there.